Hey guys, welcome back to my channel. Hope you're doing extremely well. This is your very own mask coder. So let us continue this series of solving the GFG POTDs. It's a day 28. Okay. Today's problem is reverse first key elements of Q. That is, suppose you have been given 1, 2, 3, 4, 5 inserted in a queue. Then you will have, and K is 3 here. So you will have to return 3, 2, 1. That are the first three elements should be reversed and the rest elements should be in the same order. Okay. For those of you who do not know what is a queue and a stack, queue is a data structure in which the elements stored at the first position and stored at the last position and get removed from the first position. So it is a LIFO type of format, that is last in, first out. That is, suppose you are standing in a bank line. So the first one, like there is a queue that this is person one, this is person two, this is person three, this is person four, this is person five. So if I have to remove the persons from the line, I will first remove this one, then this one, then this one, then this one, then this one. And if you see, the first person was first time. Okay, for those of you who do not know what a queue is, you have queue is a data structure implementing the first in, first out policy, also known as FIFO, the short form. All right. What does it mean? Suppose there is a line of people. Okay. A person one comes and stands in the line, followed by person 2, followed by person 3, followed by person 4. Okay. You see, the first person was 1. Okay. Now, when the line will be emptied, the first person will only leave first. That is, it will leave the line first, then it will, then it, then it. Okay. So you can see the one who comes first leaves early. Okay. So it is FIFO. Now, for the doing this question, I will tell you a approach will be which will be using stack. Stack is just opposite of the queue. It implements LIFO. That is, in this example, when one was coming before two, then three, then four. This was the order of input. So when we will remove the elements, it will be first four, then three, then two, then one. This is the stack. Okay. Stack is last in, first out. Okay, this can be visualized as you keep a stack of plates. Suppose this is your first plate, this is your second plate, this is your third plate, this is your fourth plate. Now I say that remove one of the plates, so it is but gradual that you will remove the last plates put in the stack. Okay, you can visualize queue and stack from here. These are very simple. Okay, so now what I have to do is I have been given a queue and I have to reverse the first k elements. Okay, so if you see, I have been given 1, 2, 3, 4, 5, and my final output should be 3, 2, 1, 4, 5. Now my algorithm works on the basis that stack. So if I see stack, suppose I put 1 followed by 2 followed by 3 in the stack. So it would be looking something like this. First 1, then 2, then 3. Now I evacuate it. So while I will evacuate it, I will see that 3 comes first. So 3 comes first, then 2, and after that 1. So I see that I put in 1, 2, 3 and got 3, 2, 1. So the order is actually reversed. And that is what we have to do in reversing the queue. So I can use stack as a helper now. Okay, what I can do is I will put the first k elements in the stack. So put 1, then 2, then 3 and remove them from the queue. My queue is 4 comma 5 right now and my stack is 1, 2, 3. Okay, then what I will do is I will pop them out one by one and insert into the queue, but it will not insert at this end, it will insert at this end. Okay, so while I'm inserting and popping out, it will look something like 4, then 5, then the first element from the side, that is 3, then second, then 1. Okay, but it is not my final output. I have to reach this. I still reached this. Again, what will you do? You will just remove this element, put it here, remove this element, put it here, and you will reach your final answer. How will you able to do this? So we had a queue of size n, right? We removed k elements from it, okay, and reverse it. Leave that part aside. So if we removed k elements from it, how many are we left with? N minus k. So we have to do this operation of removing and adding n minus k times, and we have to add elements to the stack k times. So that's what will be our pseudo code be looking like. So it will look like, for I going from 0 up till k minus 1, that is k number of times, stack dot push, that is dot push is used to put element into the stack. So stack dot push q dot front. Q dot front gives me the element that is to be removed right now from the queue. If we are removing the elements, it would be the topmost element in the queue that should be removed. Okay. We inserted the element into the stack, and then after that q dot pop to remove that element from the queue. Okay, this will be happening k times. Okay, after that we have got a stack. So for I equals to 0 up till k minus 1, again now put those elements from the stack into the queue back. So it will be q dot push stack dot top. Stack dot top is similar in case of stack as it was in q dot front. Okay, and remove that element from the stack. Okay, this will also be occurring k times. After that, now for n minus k times, what we have to do for I going from 0 up till n minus k, n was the total length of the queue. What we have to do is q dot push q dot front element, and then q dot pop. This is our whole pseudo code, but actually code, much mattering to the code. I have written the virtual code only here. So let us analyze it. What is the time complexity for this code? I don't think that there is a need for dry run because all the steps are actually very simple and straightforward. So time complexity would be, we are implementing it for k times, and this one was for n minus k times, right? So it would be n minus k plus k plus k. So k to k, that will be n plus k, and which is virtually O of n. Okay, and what is the space complexity? Space complexity, as you see, we are just using a data structure stack extra other than q. Okay, and what is the maximum size the stack will achieve? It will be O of k, right? Because we are storing only k elements into the stack, then that is only a purpose of stack. So it will be O of k. Pretty efficient algorithm. There was no need for brute force approach in this question, and it was, as also mentioned on the GFG, it is a easy type question. So without wasting any time, let's code it down real fast because this question was not that much complicated. So my n would be right now q dot size. Okay, the first step was to initiate a stack named as st, and then put k elements into it for int I going from 0 up till k minus 1 I plus plus. Then push the topmost element of the front element of the queue into the stack, and then pop that element out of the queue. All right, this was the first step. Our second step was to insert those elements from stack into the queue back. So for int I going from 0 up till k I plus plus, now q dot push stack dot top and stack dot pop. Second step also done. Coming back to the third step, that is push all the elements, that is n minus k elements, from the starting till the end. That is for int I equals to 0, I less than n minus k I plus plus, q dot push q dot front, and then q dot pop. After that, simple, return your original queue. This will be your answer. Hope I have not committed any mistake. And return queue, compile and run. There has been compilation error. It will be a semicolon here. I don't know how I missed it. Running fine for the sample test case. Let's see for all the hidden test case also. Yeah, working fine. Thank you guys for watching the video, and you can see our current streak is 28 days, and we will continue it further from tomorrow. And please, there is a request, guys. Please don't forget to subscribe the channel. Your subscription means a lot to me. My analytics show that still 80% of viewers have not subscribed. So please, if you have not subscribed, do hit the subscribe button. And if you like the video, please don't forget to like. Thank you. Have a nice day.